Guys, good evening. We'll be starting in just a few minutes. Vishwa is just joining in, just facing some issues while joining. Yeah, give us more 2 to 3 minutes, and we'll be starting. Hey, Vishwa. Hello. Hello. Hello.
Hey, hi, I was talking on mute. Hello, how are you doing?
Hey, I'm doing good. How about you?
Great, thanks. Thanks a lot. So,
Just give me a minute.
sure, take your time.
Hey, hi, Vishwa. Sorry, just running another session parallelly. So cool. So with that, Vishwa, I mean, I'm pretty sure you've already done. I've also done a session with you before, and we have also added the poll questions, right? So you're aware, right? How do you launch the poll questions and all the other things?
Sure, I'll do that. So I'll take care of that, so you don't have to worry on that part.
Okay, cool, awesome. So if you can just share your screen, we have a few learners who have joined us in. I'm pretty sure the learners have interacted with you in the past as well, and this is the second session, right? So yeah, we can just wait for another 1 minute and then we'll begin with the session. Yeah,
No worries. In fact, let's wait for a few more minutes till the time all the people join. I think we can wait for a couple of minutes before they join. Yeah.
sure, works. Yeah, thank you.
Guys, meanwhile, to all the people who have already joined, can you please confirm if you can see my screen and you can hear me clear and loud? Thanks, Harsh, for confirming. Thank you. Perfect, Devyans. So we'll wait for a few minutes. I think we have close to around 2023 folks. So we'll wait for a couple of minutes. Maybe, we start at 4:33, 34. Cool. So perfect. I think we have waited enough. So let's get started. And meanwhile, the folks can join in between, right? Anyways, you guys must be getting the recorded sessions, right? Are you guys getting the recording of all these live sessions that we are doing? Perfect. Then it's great, right? So even somebody is joining late, they are not missing anything. Perfectly cool. So in yesterday's session, let me just quickly summarize you, right? What all things we have. So basically, to those who have joined new today, I am Vishwa Mohan, and I think most of you were there yesterday already. So I'll not try to give any, reintroduction of myself. So I'll be taking you guys next, including today, 2 more sessions. So there are total 4 sessions. We have one we have already done on the backend APIs, and in that session yesterday, we tried to understand practically what are the different kind of API design system has been. We talked about the monolithic first, and we understood that why monolithic is not bad, right? There are certain situations where monolithic makes more sense, where if you try to do the service oriented architecture, it will be a kind of overkill, right? But then again, the monolithic had its own challenges, so we try to understand monolithic from both the lenses: one who are the lovers of monolithic and one who are the haters of monolithic. Anything that you see in the current scenario, right? Everything will have some kind of, someone who will be supporter or someone will be the opposers. Whether it's a government, whether it's BJP, or whether it's a monolithic system. It is true for everywhere, right? So the lovers will say points which are supporting the monolithic system, and the haters will say the points which so the challenges of the monolithic system. And then from the monolithic, because of these haters who have been here, who have been criticizing the different fallacies on the monolithic system, we went to a world known as the service-oriented architecture. Now, in the service-oriented architecture, we have a concept of two. One is the service provider, and another one is the service consumer. Right? These are the two entities. These people will talk to each other over the network, right? And they started talking to each other over initially something known as the SOAP, which was a simple object access protocol. And of late, they have started using something known as REST. They came to the REST only because this guy again, SOAP, had some problems. Just like in any relationship, when you go initially, it's everything so colorful, it's everything so meaningful, everything results into the guitar strokes, right? But as and when you spend some time into the relationship, you start fighting, right? So that is why you want something new, and this is how the REST came into the picture. Again, the REST is not a kind of a god which will stay forever. REST has its own challenges, and this will be further challenged. So in the today's session, mostly we will be talking about the REST. So this is what on a high level we covered yesterday. Anybody having any doubts in anything that we discussed yesterday, please feel free to ask now, so that we just sort out the things, so that going ahead we have no baggage left with us. We have all our concepts clear. Anybody having any questions on the yesterday session? Koi doubt? Kisi ko koi shak? Any problem, buddy? Are we good? Shall we move on to the today's session? Perfect. So let's go to our slide thing and see what all things that I have planned for the today's session. So today will be very interesting because you will be learning something which is very practical. So we'll be talking about the microservice, which is the latest buzz in the software industry. Everyone is trying to align their application, their products around the microservice architecture. But trust me, 90% of the people who talk a lot about microservice architecture, they actually don't understand this. So we'll try to go deep into what it is, because microservice itself is a very confusing thing. There's no clear-cut definition of the microservice anywhere. So we'll try to understand why I say that it is no clear-cut definition of microservices present anywhere and why it is confusing. Once that is done, the REST. We'll be talking a lot about the REST, what it is REST, where it is used, how do we design it, all that stuff. And this will be really helpful for you guys. When you go into the industry, when you have to build your own APIs, RESTful application, these conceptual clarity is a must. Not only for that, but also I believe that you guys must be looking for a better job opportunities to earn something better, right? So if you try for a good companies, they will definitely ask you on the questions around the REST. Once that is done, we'll be talking more about the authentication and authorization. In the today's context, when everyone and everything is going online, this is what the authentication and authorization makes sure that whatever that you're putting online is safe, and only the right person is getting the right access. So we'll try to understand what are the different ways of authenticating and authorizing stuffs when you put the things on the internet. And then, as I already said, even the rest has its own limitations. So we'll try to see what is next to the rest, what is thinking beyond rest. We'll go into that. And if the time permits, we'll also try to cover how do you think that the passwords are getting stored in the different databases, right? Time and often you must be hearing that Yahoo password account of say 50 million users got hacked. Their password were put on the dark web, right? Of late, we have been hearing that Zoom recordings of some like 5 million people in their compromised position or anything like that has been put on the dark web, right? So why it is happening? Why it is not protected? And what is the strategy that the latest and the greatest companies of the current time, how they're storing your password? How Facebook is storing your password? Because I believe most of you must be on the Facebook or Instagram. So we'll try to understand that. We'll also try to understand how the other companies like LinkedIn and Microsoft are also storing your passwords. And in the today's context, when the security, privacy, everyone is so vocal about it, what are the steps which the companies or the latest tech giants are taking to make sure that the password that you're putting to them is secure? Okay, so we'll be talking more about it. Maybe if you don't cover this one, because this is an important one, we'll be trying to cover in the next session. So this is the whole agenda of today's session. As suggested in the previous class, the rule of the house is we'll keep it interactive. Ask as many questions as possible wherever you feel that you have a doubt. Okay, questions can be relevant, it can be slightly irrelevant also, but don't start asking question about the Bollywood. Okay, only ask question related to the IT, so that we maintain the decorum of the session and should be related. Perfect. With said that, should we get started? Good to go? Perfect. I think most of the people have joined also, so I think this is the perfect time to get started. Very nice. So yesterday, one topic which was left from which we'll start today is microservices. Okay. So we have seen monolithic. What happened in the monolithic? In the monolithic, we had a front end, we had a back end, and we have a data storage layer. Everything will be deployed in a single machine, ideally. The typical definition of a monolithic system, which suppose I'm trying to design a web application. So if a web application has to be designed in the format of monolithic system, what will happen? All the three things, front end, back end, database, everything will be clubbed together and deployed on a single machine. This is how typically a monolithic system looks like. If I go to the service-oriented architecture thing, what happens in that case? What you will do, maybe you can expose the front end as one service, your backend maybe another service, and your data layer maybe another service. So these are the three services running on the three different machines: machine 1, machine 2, machine 3. Okay. If you want to further fine-grain it, if you want to, so this was the initial transition. So initial transition from the monolithic to the service-oriented architecture was this. Try to understand the chronology. Initially, monolithic system was like that. Initially, when we tried to define it, we tried to divide front end on the another machine, back end on the another machine, and the database on the another machine. When we further fine-grained it, what we further did was that even the back end was broken down into the multiple, right? Server 1, server 2, server 3, server 4. We further fine-grained it. So basically, what we did is that we started thinking that one service should be doing only one thing. Right? For example, if you go to a iPhone service provider, they only service your iPhones or the MacBooks or the iPads, but they do not service your Samsung phones, right? So ideally in the real life, or whether it's IT, to make a very scalable system, one service should be only doing one thing. This is known as single responsibility principle. If you guys have a little bit of software development background, or if you have worked on Java and know a little bit of design pattern, one of the basic design pattern for building any application is a single responsibility principle. There's a design pattern known as SOLID. And this SOLID, the S word stands for the single responsibility principle. right? So this is how. This is a monolithic system. Then it is a service-oriented architecture system. Guys, let me once say there's so much of sound coming. Just give me a second. Cool. I think it is better now. So what happened is that as and people started using service-oriented architecture, they started breaking the backend into the smaller services, S1, S2, S3, and S4, right? So this became a more fine-grained service-oriented architecture. But still, in this service-oriented architecture, there was no hard and fast rule. So what the people used to do, now you have the different services, service 1, service 2, service 3, service 4. They all might use the same database. So service 1 also is interacting to the same database. Service 2 also interacting to the same database. This also interacting to the same, like this. So this was also called the service-oriented architecture only, but more fine-grained because one bigger backend service has now been divided into the smaller services. So this is how we have been trending. So maybe this was the initial style of 2000, and then later on people started, understanding it well. So in the later 2007, 8, something like that, they started doing it like this, in which we have the more fine-grained services. This point is clear? So far, so good? Any doubts on this? Are we good? Am I audible? Am I breaking today also, just like yesterday? Bolo? Perfectly fine. Okay. So this was something around, around 2007, 9, around. This was the practice. But later on, off late, if you see for the last couple of years, what happens is that people have started saying that, okay, instead of service 1, service 2, service 3, service 4, something like this, having the same database, right? Now these service 1, service 2, service 3, and service 4 are independently deployable system. They are the independent application, but they still somehow are related to each other. So for example, because of S4, if S4 is writing at a very high speed, okay, because of which say this database has went in a the whole bandwidth of the database is being occupied with S4 service itself. So at that time, at the peak time, and the S4 is writing at a very high pace to this database. Suppose S2 wants to write or S1 wants to write, they have to wait for it. So basically the performance of S1 and S2 will get dependent on S4, right? So even though if I say that S1, S2, and S3 are the 4 different, independent application, but in the background, since they're using a single database, it might indirectly affect their performances, right? So that is how they, the proponents of the services, they said that let's try to have a system where each application should have their own database also. So this is service 1, it's a database 1, service 2, and it has a database 2, service 3, and it is a database 3. So this highly fine-grained system of service-oriented architecture, where each service is not only independent of each other, they're not only separately deployable, but they have their own data storage layer also, started being called as microservice architecture. So if somebody asks you, is microservice architecture a service-oriented architecture? The answer is yes. The microservice architecture is just a service-oriented architecture, but it is more fine-grained. Just like how, whenever something changes, it doesn't change over a night, right? Similarly, when we moved from the monolithic system, we didn't know everything in the beginning itself. So we have evolved, right? So from the monolithic system, when we started, we had you have a transition like this. Then we further had a transition like this. And then finally, we have a transition like this. And maybe we can further have a transition after this in some other form also. So there are different kind of architecture like lambda architecture, functionless architecture, serverless architecture. So these are the evolutions, right? Just like in the humans, we started from the small protozoa, right? Then we converted to the different, we moved into the monkey, then we became the, the wild people, right? And today we are in the most sophisticated format in which we prefer wearing jeans and shirt, right? Even though we are the animals. Similarly, in the case of the services, we started from the monolithic system. We went to the service-oriented architecture world. In the service-oriented architecture world, we again, improved ourselves like this, from this stage to this stage. And finally, today is the time when we are using one of the most fine-grained approach of service-oriented architecture, which is a microservice architecture. So what is a microservice architecture? A microservice architecture is the kind of architecture design in which there are multiple independent service. And when I say independent service, they also have their own independent deployment lifecycle, and they also have their own data sources. Two services in an ideal microservice architecture will not depend on a single database. So if somebody is designing a system and they're calling it that, okay, it is a microservice, but if your applications are sharing your database, it is a service-oriented architecture, but it's not a microservice in a true sense. Does that make sense? Do you guys agree with me? Boliye. So Tarun, you don't need to keep D1, D2, D3 in the sync. So I'll give you an example and it will make more sense. So for example, which application should I take the example for? Say like for example, Facebook.com. Okay. Now the Facebook.com, the user wants to log in. Okay. So there will be a login service. Okay. There will be an authentication service. And there will be some, maybe the risk service. Okay. The login service will have its, maybe, it will have its own databases where it will have stored the user details. The authentication service will have a DB which will have a user and password mapping. I'm just giving you an example what could be. And the risk service will have the data related to any fraud patterns. Right? So now when the user logins, he makes first call to the login service. Now login service will check in its own database, in its stored as layer, whether this user detail is present in us. Yes, it is present. If it is not, it will return from here itself. But if it is present, this user service may make a call to the authentication service. That okay, this user is in our system, but can you please say if he is the same user he's trying to say? So authentication service, what it will do, it will try to check his username and password, and okay, if it matches, then this authentication service will try to make sure that, okay, let me check if it is a hack. Is this account compromised? Let's try to see the pattern. He may call the risk service. Now risk service will have its own data storage layer where they will, have the data for that fraud related patterns, try to match it. If it matches, then say that no, ask for some extra OTP information. In the case if say that no, it is fine, there is no fraud pattern here, so it will return okay, this will return okay, and this will return that okay, you can sign it. So this is the example of using the login service is a separate deployable system which will have a database, authentication service is a separate deployable system which will have a database, and risk service have a separate system which will have their own database. If this is what a ideal microservice architecture is. If this is not, if I go 5 years back, how they would have done is that at that time maybe Facebook was not very big. Facebook was small application, so data was also not big. So what they would have done is that in the same database, they would have also stored the user information in one table, user information in one table, the password information in one table, maybe the risk information. So this login service is also calling the same database, authentication service is also calling the same database, and the risk service will also call the same database. Now this is a service-oriented architecture, but not the true sense finely grained microservice architecture. Does that make sense? Tarun? Everybody who's here? Are you guys good? Samajh mein aaya? Now this is a very important question. Not only for the interview, but for your understanding also. Understand what is microservice architecture. Because if you don't understand it, you will not be able to do the justice when you are actually working in the industry. And the second thing is that it's a very probable question. If anybody is interviewing for a backend role, and if you have mentioned microservice in your resume, take me from the written that they will 100% ask you that what is microservice architecture and how it is different from service oriented architecture. So you should have and they will try to confuse you like hell, right? So you should be very clear that microservice architecture is something which is new, which has just come like fast few years back. It is an old concept, and the basic concept is service-oriented architecture. But when we have evolved service-oriented architecture over a period of time in which we have made more fine-grained, such fine-grained that each individual component in the system, which is a service, is self-deployable. They are only responsible for doing one thing, and their data storage layer is also not shared. At that extreme stage of service-oriented architecture, we start calling it microservices. ठीक है ना? Make sense? You will guys be able to explain? Somebody asks you? Bolo. Perfectly fine. So great. So let's move on. So this point is clear, right? So let's go to the slide and see if we missed anything. So the same thing, right? So on the left, we have a service-oriented architecture in which the different services are saying the same database. In the microservice architecture, you have each application will have their own database. And service-oriented architecture and microservices are basically one and same thing. Microservice architecture is just a more fine-grained service-oriented architecture. Okay? Now, let's try to understand. Everybody is clear on the microservice architecture? Batao? Anybody having any doubts? All good? Great. So now let's try to understand what you feel now. So what happens is that if I have a microservice system. Okay, so for example, let's try to take another example. Which company you want me to take example of? Any suggestion? Any company that you want me to take care of? Amazon. Okay, perfectly fine. So say it is Amazon, okay, and we cannot cover everything comprehensively, but we'll try to take few. So for example, let's take a use case of user buying a product. Okay, so for a user to buy a product on the Amazon, the first thing that he need to do is that he need to do a search. So there should be a search service, right? And the search should have its own DB. Okay. Once he is able to search, right, he should be able to add it to a cart. So there should be a cart service, and the cart will have its own, right? Once it is added in the cart, what do you need to do? You should have a checkout service, right? And the checkout should also have some kind of OMS, order management system, which is order management system. It should have its own layer, and then there should be something like shipment, something like this. There should be a service for sourcing. So what is the meaning of sourcing? Basically, every time you select an item, you should be getting some dates, right? By 2 days I'll get an item, or by 3 days I'll get an item. So there should be a sourcing service also. So that will have its own system, and then finally there should be one payment service. There will be much more than this, but I have just tried to put a high level different services that will be needed. Okay, so suppose there is a user here. He will try first to search for elements, so it will hit the search service. If he selects that item, search service, it will go to the cart. After that, it will go to the checkout. If checkout, I'm confirming, it goes to the order management system, right? And here itself, this also will be calling the sources to get the dates. And finally, this checkout will finally call the service to get the latest state information, which will get updated, right? Finally, when you confirm, you said that, okay, this order will be delivered by this much of time. And then order management system will give a call to the shipment to start the shipment. And from here, you will also make a call to the payments to do the payment and all that stuff. So this is how a typical flow will happen. So what I see, there's so many moving pieces. There's one moving piece is one. In this very simple design that I have made, now, trust me, the design is very complex. When I was working for the Walmart.com, I was a part of this whole flow itself, right? So suppose it is 1, 2, 3, 4, 5, 6, and 7. There's 7 different moving pieces, and trust me, there are much more. There must be more than 15 different services which will be interacting to each other, right? And believing that everything is a microservice architecture in the Amazon as of now, can you guys tell me what are the problems with this design? What is one of the biggest problems that you see? दिव्यांश अगली दफा लिंक्डइन लेंगे हाँ अभी अमेजन पे काम चलाते हैं any problems that you guys see in this system? Anybody? What are the biggest problem which Amazon has to face if they have a system like this? Network dependency, too complex. If one service goes down, entire system is down, all dependent on each other, right? So normally, if one system goes down, उसके लिए क्या करते हैं ना, in any company like Amazon or Walmart or Flipkart.com, what they do is that they have a backup policy. Suppose if cart goes down, so it will have some kind of RR thing, that is rapid response. What is the meaning of that is, it will not do any logic, it will just do a default thing. So that is how they try to manage. So normally, they try to avoid any kind of failure. So suppose in the search, it's called the cart. If the cart doesn't work, there will be some default tool that, okay, it will directly go to the checkout in order to minimize as much as possible. But that is again a design decision, but you are right. This system is very complex, and if you don't care of that, there is a point of the different problems. The problem is, first of all, it is too complex. And not only complex for the end user, but also the developers who are developing it. So if developer is not very aware of what ideal microservice should look like and what it should be, it leads to the confused developers that we already talked about. Confused developers. The developer themselves are confused, right? And if the developer themselves are confused, what will happen? They will not be able to design a good system, right? The second one is the network dependency. Network. So the lag may increase. If you see in the left hand side, this is network call. Everything is a network call. Every service calling another service, there's a network in between. And network is one of the most unreliable thing. And we have seen that yesterday, right? And today also I'm just, दूध का जला छाछ भी फूक फूक के पीता है. So I'm feeling very aware today that, okay, am I audible or not? Am I audible or not? Just because the network is in the play, right? So network is one of the most unreliable things. So that is another problem, right? I think few of you guys all dependent on each other. Why are we maintaining a separate DB for each service? Can't we have everything in one DB? Is it maintaining different DBs at different requests to one DB? So Ravi, this is what I was explaining you. The proponents of the microservice architecture, they say that there should be a different database for the different services. And it's logical also. I'll try to convince you why. Okay. So in the market today, there are multiple kind of databases. On a high level, there are two. One is the relational, and there's something called NoSQL. Okay, the relational, there are multiple players: Oracle, MySQL, Postgres, right? Then Microsoft's. There's so many others also. In the NoSQL, we have like MongoDB. Okay, you have Cassandra, you have Redis, right? There are multiple, right? So okay, so what happens is that each database has its own beauty. Okay, so normally relational databases are more important when you have a transactional use cases, right? I'll not go into the detail because this is the purpose of the database, but I'll just try to give you a high level. So each database has its own purpose. So for example, whenever you have the transaction is involved, right? Whenever there's a relation thing which is important, right? In those cases, we normally go with the relational databases. Now, out of the relational database also, everything has a different meaning. So for example, if you want a very specialized operation, you want a very high quality things, right? In that case, Oracle paid solution you normally take. If you have some internal tools, where you want the relational, but you don't want that much of quality and the control. You don't want any specialized solution. You go with the MySQL kind of thing. Postgres provides some more additional functionalities apart from the regular thing. So in those cases, you go with the Postgres. Similarly, suppose somewhere your schema is dynamic, right? So if the schema is dynamic, in that case, we normally go with the NoSQL kind of databases. When your data is too big that it cannot lie in a single machine, then also you go with the NoSQL kind of databases, right? So if you see in this Amazon.com, the different systems will have the different requirements. So for example, the payment, the transaction is important. So maybe here I'll be using Oracle, right? In the search, since there are different products, the different products will have the different dimensions. So here maybe I'll be using something known as MongoDB, right? Maybe the order management system, I need to have the relationship between the different entities, shipment, payment, and all that stuff. So here, maybe I'll use MySQL, right? So the purpose is that when you have the option of having the multiple databases, you can choose which is the best suited for that particular service. But if you have a single database concept, even though you feel that that database will be more helpful, but you're forced to use the old tech stack, and that was the limitation of the monolithic system. And that is why it's make more sense that every service should have its own customized dedicated database. Does it answer your question, Ravi? Ravi, is it fine? Can't I create two services pointing to the same DB? Ravi, so your question is, can't I create two services pointing to the same DB? You can do it. See, service-oriented architecture is not binding you for anything. You can create 5 different services, we can point to the same DB. But that will be a service-oriented architecture. That will not be a microservice architecture. So you can say that I'm doing a microservice architecture, but in your internal system, you're calling 2 APIs, 2 services with the same database. But if you're doing that, then that is not an ideal microservice architecture, right? This is what I'm trying to say. There's no one stopping you to do that. If your business requirement is that single DB is enough, go for it. No one is stopping you. But that will not be a pure form of microservice architecture. And I'm saying that you don't need actually a pure form of microservice architecture if it is not business justified. So you take a call based on your business requirement. If monolithic system makes sense, go for it. If a middle one, which is a service-oriented architecture, if that makes sense for your business, also go for it. So based on the requirement, what you're trying to build, what your business use case is, take a decision on that. Don't take decision on this fact that, okay, this microservice is in trend, so I will go and do microservice. Don't do that. Try to understand your requirement in the industry, what you're trying to solve, and then try to see which system suits me well. If it is a microsystem that suits you well, go for that. If it is a hybrid, then go for service-oriented architecture. If you feel that, no, I want a monolithic will make more sense, then go for it. So this is what the point that I wanted to make. So Tarun, hybrid means this one, right? So basically this microservice architecture, see, as I told you, this one. So basically if you see this one, so this has the features of both a little bit of monolithic and the service-oriented architecture also. Because a single backend is there, right? In which there can be multiple services. You have not broken it. So it has few features of the monolithic also. And it has few features of service-oriented architecture also, because DB layer you have separated, front end you have separated, and backend you have separated. So this is what I mean when I said the hybrid wala thing. At what point Selvan decided the application need to move from the monolithic to service-oriented architecture? What would be an example of justifiable business decisions? Very perfectly fine question. So for example, I'll take you the life cycle of one application, suppose, okay? Suppose, very nice question. Let's try to understand. So Anwar, suppose tomorrow, after getting all the gyan from the upgrade sessions, you, Anwar, decided that, okay, I have some plan. I'm good developer. Let me create another edge tech company, just like Upgrade or something like that, or any other domain, right? So now, since you didn't have much resources, you are the only one who's working on it. So, and you also had the minimum resources, because again, for the microservices, you need to have more money. You have to have the multiple machines. You had only one laptop with you right now, okay? So you developed some application. and everything, whatever the front end, back end, DB, everything you put into a single machine. Front end, back end, DB. It's perfectly fine. Initially, the first stage was your laptop itself in which you developed. Later on, you felt that, okay, laptop is not looking good because if I shut down, the application is not available. Let's try to put in some cloud providers. So you try to, find some, some cheap cloud provider. So AWS has some free accounts also. So suppose AWS only you go and deploy in some EC2 machine. You deployed all the things, front end, back end, and the database layer. Okay, now it is fine. People started using it, and then you got to the investors. You get good funding. You liquidated it much more. Okay, and now you feel that more and more people have started using it. Now more and more people have started using it. What has happened is that now you are seeing that one machine cannot take the load. So what you do is that instead of deploying on a one machine, you have deployed the same thing on multiple machine, M2, M3. So now it is scaling up, but still it is monolithic only. But you are not an average engineer. You are a very smart engineer. What you have realized is that, see, now this is a monolithic system. To scale it, I have deployed into the 3 machines. 1, 2, 3. But I have seen that most of the users are not making any changes to my application. They just come there to see the content on my application. It means that the massive load was on the front end layer. It was not on the back end or the DB layer. But what I'm doing here now is that the maximum load is in the front end. But since I have to, scale the front end, forcibly I'm, scaling my backend as well as database layer also, which is not important. And since I'm forcibly doing this, AWS is unwantedly, charging me more because there was no need of scaling services. There's no need of scaling database. And without any need, I'm scaling those things just because I have a monolithic architecture. I'm paying more. So this time you have to do a cost need analysis. And you start feeling that, okay, in this system of architecture monolithic, I have to pay unnecessary cost because of which I'm just following this pattern. So I think this is the time where you should, you should start thinking of, no, now I should take a call and I should try to divide this whole system into my front end, back end, and the database layer. And now you divide front end on a machine, maybe 3 machines, M1, M2, and M3. Okay. And this is still on the one machine, M4, and this is the same machine, M5. And now you are scaling this up. Tomorrow it became more famous. More people started using. So now call from here also started increasing. So now you have to scale this also. So you first started scaling it by having it in the multiple machines. M5, M6, backend, like this you did. And since backend is more, so your database is also getting more load, so there's more data, so you cannot store in a single machine, so you have more databases on multiple machines. So this is how you're moving in the service oriented architecture. But later you realize your backend is also a big code. The backend in itself is a big code, is a big mess. Every developer has to work on a single piece of code, which is getting tough because it has become very, very complex. So the next phase, what you do, you try to divide the backend into the multiple parts. So whole backend may be divided into the 4 services: service 1, service 2, service 3, and the service 4. And initially, whole the service S1, S2, S3, and S4 was all relying on the same database, right? But later, some cool engineer got hired in your company, and you hired the greatest engineers of this world. They will tell you, guy, this one is transactional, so this makes sense. But these guys are schema-less. Every time we have to keep on updating the schema, which is a tedious task. What should I do now? So he will say, okay, let's have the separate DB for everyone. So here it becomes, the S1 gets its own form of the DB. S2 gets the own form of the DB. The S3 gets the own form of the DB. And how you convert that into the microservice architecture. So you see, this is a pattern. You have to go from stage 1 to stage 2 to stage 3. Never try to jump directly here, because if you jump directly here, you will not be doing justice, because you don't know what problems you had. You're just trying to do over engineering. So this is how a normal path happens in any company. You take example of Google, you take example of Facebook, you take the example of the company in which I work as of now, which is LinkedIn. They all have been through the same phases. And this is how the architects, the senior developers, the techies, they try to think in this direction and they try to upgrade their system. I hope that answers your question. Anwar, does that make sense? Cool. Anybody having any other questions? Cool. I think everyone is cool now. Shall we move ahead to our next topic, guys? All good? Everyone is clear? Let me take a quick note down from everyone. Avinash, Manashwani, Devyans, Syed, Aditya, Poonam, Shrestha, Kumar. Are we guys good? नींद आ रही है? Are you guys sleeping? Anwar, Ravi, Divakar, Abhinav, Mamta, Pratap, Deepti, Tarun, Bindu. Are we guys alert? Perfect. Great. I know that you guys are not sleeping. I was just, pulling your legs. Cool. So let's move on. But before that, let me, put some questions if there's anything else. Okay, I have a question on your screen now. Please try to answer this question with best of your judgment. So I think most of you have got it right. Service-oriented architecture always better than monolithic. This is a wrong statement that we have already seen. There are certain scenarios in which monolithic is much, much better than service-oriented architecture. When you are just starting up, when you have the limited resources, when you don't have enough money to buy multiple machines, definitely in that case you should go with a monolithic system. Two, when your system doesn't is not taking too much of load, when your system doesn't have any scalability issues or any scalability requirements, when the scalability is not in the picture, you should always go with a monolithic system. When the number of developers working on a project is one or two, very few, in that case also monolithic makes sense. When you have a system where the speed is very important, you cannot go for a very high latency things, right? In that also monolithic makes sense. If you have to make a system which should be very, very secure, you have a security concerns there, then also the monolithic makes sense, right? When you have the developer who is not aware of the newer system designs, and you cannot say blatantly that okay, developer has to be ready for everything. It's not very practical. When you work in the industry, there are people with a different background and the experience that they come and play, right? And you have to always have to strike a right balance between the ability of the developers and the project that you're working in, right? So in certain cases you may not have the competent team to work on service oriented architecture. So instead of making them struggle on the service oriented architecture, try to make them work on the things in which they are best at. So in that case also the monolithic makes more sense. So in those situations, monolithic is much better than service oriented architecture. So if one of you is working on a monolithic system, you don't have to feel bad. Next time somebody frown upon you, just tell him, hey man, monolithic is great. Okay, there are certain situations in which service oriented architecture can never replace monolithic system. Clear? Everybody agrees to me? Bolo. Cool. The next thing is, and I asked you guys to read about it. So I'm expecting that you must have the answer. Okay. So rest. This is the next topic. And the rest is representational state transfer. Okay. Okay. I think most of you would have heard about the rest. Is that true? Have you guys heard about the rest or ever heard someone whispering about the rest in the office or somewhere in your house or somewhere in the coaching? Okay, few are no, it's perfectly fine for them. But I think most of you are saying yes. Okay. If this is the case, ठीक है, then you have must also heard this thing called rest is stateless. Have you guys heard this statement? Rest is stateless. Okay, if you have not heard it, it's very nice. To those who have heard it, it's great. And just for everyone's interest, this statement is true also, fortunately. Rest is stateless. Okay. Now, before we talk anything, let's try to first define something called what is state. What is state? Can anybody help me understand the meaning of state? I don't want any technical jargon. I don't want any bookish language. Help me understand, treat me if I'm a 5-year-old kid and help me understand what is the meaning of state. And mat bol dena state matlab Karnataka and state matlab ki Maharashtra. Okay. I want state in the terms of IT field. State, you are saying position. Okay. Anybody else would like to try? What is the meaning of a state? Assume it as some process. Okay. Are you guys aware of Java? Have you studied Java? Is Java as a part of this course you have been enrolled? Shape and mode. Okay. What kind of language Java is? What kind of language Java is? It's like a snapshot of a situation. Right. Nice. Object oriented. Perfectly fine. How do you define an object? How do you define an object? Anybody who can help me understand a very lenient meaning of objects? What is an object? An object is an instance of class. Divyans, I'll just give you a very simple example of my life. And when I was a kid, I used to read a very funny story. There was a guy who knows to write essay only on the cow. Okay. And throughout his preparation for the exam, he only remembered what is cow. So he know that cow is an animal. It has 2 eyes, 2 ears, right? 4 legs. But in the exam, he was asked write an essay on the river. So what he did, he said that, okay, there is a cow near river and the cow has 2 eyes, 2 ears and something like that. So I asked you what is the object and then you told me it is an instance of class. Object is anything with the same attribute and the same functionality. Object is an instance of class. Manushni, you are also doing the same thing. Object have state and behaviors. Yes, Mamta, you are right. Okay, so let's try to talk about a little bit about the object and then I'll come to the state because everything is interrelated. Let's try to keep our concept very crystal clear. Let's not have any scope of doubt. So object oriented programming. Let's take a small dip. I think this is not a context but I will tell you because this will help you clear your concept. Why object oriented programming you need to study? Whenever you would have studied Java, you should have definitely asked this question to yourself. Why object-oriented programming? Any company that you see who are solving a very complex problems of e-commerce, problem of relationships like Tinder, problems of the transportation, every company uses an object-oriented language. Mostly Java, otherwise something else like Scala or Python, something like that. But they will use an object-oriented programming. Reason why? Because the problem that we are solving these days are highly complex. They are relational. We are solving the problems of the real entities. And anything in this world, the real life, any real entity in this life, they are either the living or non-living things. But whether it's a living thing or a non-living thing, they have 2 things always, right? Both the living and the non-living things has 2 things always. One thing is state and another thing is behavior. And I'm talking about the state. What is the meaning of the state? State is basically attributes in the terms of. So in the terms of the living or the non-living things, when I say state, so for example, if I'm talking about a person, the person state can be age, His state can be name. His state can be, gender. And when I say about the behavior can be he can speak, he can talk, he can move, he can dance. If I'm talking about the non-living things, say car, it has a state like model, number, color, brand. And if I talk about the behavior, it is the methods. Behavior, basically you can drive it, you cannot do it, right? So these are the real life entities. Today the problems are complex. We are trying to solve the real life problems. And when we are trying to solve this, we need to have some kind of programming language which can mimic this. You cannot do that with the C kind of language, the procedural language, because that only talks about the steps, functions, one calling one another. You have to solve these complex entities and the relations in between them. You have to have a language which mimics that, and that is why we need to do the object-oriented programming. And the core of the object-oriented programming is what? Object. So what is object? Object is something which has a state and behavior. What is object? Object has something which has the state plus behavior. The state is what? State is basically the attributes which defines it. So for example, if an object is a car, so its state will be the, the manufacturing year, who the manufacturer is, what is the color. This can be the state of the object. The behavior is that it can go to it can drive, it can brake itself, it can accelerate itself. So those will be the behavior. So what is an object? Object is something which has a state and a behavior. What is the state? State is the attributes, the features which distinguishes you from the others. This is what the meaning of the state is. Everybody clear? Anybody having any doubts on object, state, behavior? Batao. Clear? Everybody agrees with me? Everybody understand why object-oriented programming language is needed? Why it has become so crazy? Everyone is so crazy about using object-oriented language these days. Very nice. So now let's take a step back. Now we have understood the state. What is state? Okay. So stateless means there is no state. Stateless means there is no state. Okay. So to those guys who already know that it is a stateless, it is fine. And for those who don't know it, I'm telling you that it is stateless. This is the correct statement. So at one go, I'm saying that REST is stateless. And the full form of the REST is representational state transfer. Don't you think these two are contradicting to each other? The full form of REST is representational state transfer, right? And we are saying that it is stateless. Don't you feel this is an oxymoron? These two things are contradicting each other. Anybody has done their homework? Yesterday someone was asking me, "Sir, what should we do as a homework?" Have you guys done your homework today? Can anybody help me understand what is the meaning of representational state transfer? कोई homework करके आया है? या फिर कल पूरी रात नेटफ्लिक्स पे सिनेमा ही देख रहे थे? Maybe transfer of object state. Can you explain this? What do you mean by this, Ravi? Anybody else? As we just talked about, object has state and behaviors. It does not store any client session on the server side and thus making the REST API less complex to develop and maintain. That is fine. So Sayed, this means that it is a stateless. I'm talking about why it is called representational state transfer. What is the meaning of this? Not storing the client session on the server side, it means that it is stateless. Agreed. But why it is called representational state transfer? What is the meaning of this term? I just want this to be broken so that you guys understand the meaning of it. There must be something, no? That why we call it representational state transfer. Representation of any resource contains the mean for an application to change to a different state. Okay, to some extent, but can you make it more clear? Cool. I think to some extent you guys are right. Let's try to understand it in a very simple way. Okay. So let's try to understand the meaning of representational state transfer. If you hear it clearly, with a lot of focus, trust me, you will never have doubt and you will never forget this. If an application is there, there will be a front end, okay, and there will be a service layer, that is back end, which is a service layer, okay, and then we have our database layer, okay. What happens here is that front end may call this one, this may call the this, this. Your data actually is stored somewhere in some table in this DB. Okay. And in the DB, just take a very simple example of say Oracle or MySQL. A table comprises of the attributes, right? And we have already seen that the attributes is what is known as the state, right? The attributes of an object is known as the state. So the actual state of the object is stored in the form of some tables in the database. So the state is always, stored into the database. Now what happens is that this front end makes a call to the service layer, and this service layer makes a call to the DB. And from this DB, this data first gets serialized. It gets serialized. Okay. Goes over the network, come here to this, it here get deserialized. Here it gets converted into the JSON format. Okay. From the JSON format, again it gets deserialized. Sorry, it gets serialized. Goes pass over the network, comes here get deserialized. Converted into the JSON again, and from the JSON it gets converted into some kind of visual images or graphs. So what do we see here? The state of the data which is stored in the database, the state of the resource. Actually, to the core of any REST API is a resource. We always call it as a resource. So the state of the resource means the different attributes of the resource. It is persisting in the database, but its representation form. Initially, it was somewhere stored in the form of bits and bytes in some hard disk. Now, its representation form has been converted into the serialized, and it is getting transferred from here to here. And then from the service layer, it gets converted into the JSON. It's again representation changes, right? And then again that JSON gets deserialized, and again it comes back here, and then it again gets its representation changes, and its representation changes into some kind of visualization finally on the UI, right? So basically, what we are doing is that we are transferring not the data, we're not transferring the state, but we're transferring the representational, the representation of the state from the one system to another during whole course of the transfer. We're transferring the representation format of that data, and that is why we call it as a representational state transfer. REST is what? REST is a representational state transfer. Make sense? Does it make sense? So this can be anything. So REST doesn't say that it has to be JSON. Okay, the REST doesn't say that it has to be JSON. You can also use XML here. It can be anything. You can even use Avro schema. So REST is independent of JSON, guys. I just took JSON because 99% of the REST APIs are built based on the JSON. So that medium can be anything, but the concept here is that you're transferring the representation of the state. Okay. Avinash, that answer your question? Devyans, let me read what you're saying. When we want to move to a different state, in the application, so we don't usually go to your URL bar and enter in a new URL. Instead, we will click on a link on the current page that will take us to. I didn't get it, Devyans, exactly what you wanted to ask. Devyans. Okay. And that repository can be JSON, XML, or anything else, right? Yes, Aditya, you got it perfectly right. It hasn't to be JSON. It can be anything. So REST is open to be, used with the different kind of representation formats. It can be a JSON, it can be XML, it can be Avro, it can be different things. Okay, so it is not bound to anything peculiar, right? You're right. Anybody else? Is it clear? No problem, Devans. I got you. I got your point. Anything else, guys? Is it clear? सबको clear है? Perfect. Let me see what is there in the slide so that we don't get deviated. Okay, this is fine. Perfectly fine. Okay. Okay. Before this, let's try to talk few more things. Few more things are important. Okay. Few key features about the REST is it's supported over HTTP. What is the full form of HTTP? What is this? Anybody knows? What is HTTP? What is HTTP? Hypertext Transfer Protocol. Okay, so basically it is a protocol that we use at the application level layer for the transfer of the data. Okay, so since it is supported over the HTTP, so basically it supports 4 different HTTP verbs. 4 different HTTP verbs by default. One is the post, 2 is put, get, and 4th is known as the delete. These are also known as the CRUD operations. C stands for the create, which is post. R stands for the read, which is get. U stands for the updating, which is put. And D stands for the delete, which is 4th one. Okay. So HTTP supports these kind of 4 HTTP verbs. Now, one very common question, I think you guys will be already knowing it. So quickly answer it if you know it. Out of this, there's a concept of a service can be idempotent or non-idempotent. So let's try to first understand the meaning of this. What is the meaning of idempotent? What is this? Anybody? Pratap, why you have put the less than symbol? Is that signifies anything? Are you comparing these things? Okay. No problem. So can you tell me what is the meaning of idempotent? Can be called many times without different outcomes. What is this? This is idempotent or non-idempotent? Idempotent. Very nice, Divyansh. So idempotent, a process will be called an idempotent if even if you do 1 time, 2 time, or billion times, the outcome will remain the same. So for example, suppose you are trying to check the balance in your bank account. Okay, you checked it first and you saw it. Okay, अरे 5 रुपया ही है. You got feel bad. You checked it again. And you keep on checking it 5 billion times. Even if you check billion times, if your account has only 5 rupees, it will show only 5 rupees. It doesn't matter how many times you check it. So this kind of thing is known as the idempotent, right? So in the term of the RESTful APIs, few of the offerings which is present in the RESTful APIs, for example, get, which is searching, is a idempotent. Put, which is an update, is also idempotent. So for example, suppose I'm trying to update the name of the Roshan to Vishwa. So even if I update it once or update it 100 times, it will not have any side effect, right? So updation also is a kind of idempotent operation. The get is also a kind of idempotent operation. Delete is also a kind of idempotent. So if you delete something once or you delete something 1,000 times, nothing, no other resources will get impacted, right? So these are the idempotent services. So when I do a put call, when I do a get call, when I do a delete call, these are all the idempotent services. only one out of all these, which is a post, is a non-idempotent call. What it means is that every time you call a post, a new resource will be created. So if I call post 3 times, every time this will result into creation of a new resource. So every time you do it, a new change will happen. So that is why this is known as the non-idempotent. So this is known as the non-idempotent. Cool. Now in the REST, the core to any REST API is, the core to the heart and the soul of any REST API is a resource. And what is a resource? Resource is nothing but a noun or something called data. The data itself is a resource. No? Everyone is talking these days about the data-driven decisions. So everything is revolving around the data. So the whole concept of the REST revolves around something known as the resource. Okay. So when I say post, it means I'm creating resource. When I say put, I'm updating resource. Try to understand the terminology. Right? When I say get, I'm trying to read or search the resource. When I say delete, I'm deleting the resource. Okay, so everything that we do in the terms of the resources. And when I say post, I'm creating resource. And when I say put, I'm the updating resource. When I'm saying get, I'm getting the resource, right? And when I'm delete, I'm deleting the resource. This is what the meaning of this. Okay. But another key point about the REST is that, is REST is like your mom. Typical mom. Okay, I'm not talking about very stringent moms, but a typical mom. Normally, moms are like, they're very easy convinceable. The moms will always give you some suggestions, right? They will always try to give you some guidelines. But sometimes you can always override that. And your moms are so understanding that they say that, okay, it's fine. For example, the mom has told you that you have to come back by 10 p.m. in the night, but you end up coming late, like 12. She will get a little angry, but somehow it's easy to manage. Similar is the REST. So when the REST said that post will be used for the creation, put will be used for the updation, right? Get can be used, should be used for the finding, and delete should be used for the deletion. These are just the guidelines. These are just the standards. Okay. These are not binding on you. Okay. What it means is that you can create a get, but inside the get you are creating something. So then get becomes non-idempotent. Get was only purpose was to find, but inside the get API you have started creating something. It's wrong thing. You're doing wrong, but nobody can stop you, right? Only they can give you suggestions. So REST is not enforcing any rule. It's not a rule maker. Just keep this in mind. REST is just a standard. It's just a suggestion. Just like sometime back, one of you told me, cannot I have two services pointing to the same database? You can definitely have. Nobody is forcing you to do that. Not do that, right? It's just a standard. Microservice is just a standard. Similarly, when I talk about the REST, it's just a standard. It's a standard practice that the post should be creation. Standard practice that put should be updation. Standard practice that get should be finding. Standard practice that delete should be deletion. But no one is forcing you. You can if you want, you can do creation inside the get. If you want, you can do the searching inside the post. But if you do that, you are defeating the whole purpose of REST itself. Because if you design system like this, you will not be able to integrate your system to any other external system who are standing the formats, right? So this is basically like just like in the case of the drugs, in the case of the units. For example, the unit of measurement of the weight is kilograms. It's a standard, so that everybody across the world we can exchange the amount. If we don't follow the unit standards, right, we will not be able to exchange items with the different countries. Similarly, when you're working in the IT ecosystem, Every company these days are building their REST APIs and exposing to the end world. For example, Twitter has their developer APIs, LinkedIn has their own developer APIs, Facebook has, Google has, right? And they've exposed it to the external world. And when they have exposed it to the external world, they have said that I'm complying to the standards of REST. But they're not forced to, but they're complying. So the point that I want to make it here is that when I say post, it's not binding that you have to create only in that. But if you are following a standard practice, if you are trying to follow the REST regimen, the post should be doing creation, the put should be doing updation, get should be only used for the finding, and the delete API should be used only for the deletion. In the post, in the put, I have seen many other people in the industry and otherwhere else also, they only not do updation, but they also do the creation, which I feel is a bad practice. So normally, all the creation should go to the post. Put should only handle the updation. Get should search an element, and delete should be doing the deletion. Make sense? Anybody having any doubts? Bolo, are you guys good? Perfectly fine. So, do you guys have any? Do you guys are you working on any practical projects on the REST APIs? Have you built any services or anything like that? Have you guys taught? Okay, okay, okay. So, let me tell you one thing, which is now we'll talk about the designing standard REST URI. And this is very important, guys. You should be knowing how to design a standard URI. Before I do that, let me give you an example. One URI may look like this. Get, it's a get call, it is indicating that, and it may be like HTTP and maybe local host 8080. And suppose a user management is suppose your service. So you write like this, user management and REST, and you call it like user service is the service name, and you say get user, and you have something like this. Can anybody tell me, is this URI fine as per the standard? Any issues that you see in this? So this is a typical URI. URI means uniform, unique resource identifier. Just like every one of you have a unique address, so that if I send some money to you guys as a postcard, it can reach you. Similarly, in the case of the REST, every resource have a unique identifier, and that is known as a unique resource identifier. So a RESTful API URI looks something like this. Can anybody tell me, do you guys find anything wrong in this? Anything wrong in this? And if you find anything wrong, can you just tell me what is that? Have you played that game in your childhood in which there was an image and in that you have to find 10 mistakes very quickly? Similar like this. Local is fine. You don't have to worry on this. Okay, this you can replace it with anything. So basically, you can replace it with any server. So this thing you can ignore. This you can ignore. I'm more talking about the URI part. This will change, right? Based on the machine on which it is required. So don't worry on that. Divakar, you can ignore that. I'm not asking that anything missing. I'm saying, is there anything wrong? Is there anything wrong in this URI? I'll again go back to this one. Just have a look at it and tell me, is there anything wrong in this? Anybody found any fault? User ID visible in the URI? That will be visible, Aditya. User ID has to be visible. Okay, I'll tell you what the problem is. The problem is this. Get user is a verb, and verb is by standards of the REST URI should not be used in the RESTful API. Okay, everything is pointing to a resource. In the RESTful API, everything is pointing to the resource. And what verb means action, what you're going to do, and what action you're going to take on the resource is represented by this, the HTTP verb. So the verb is this one. This is my verb, and this is my noun. Okay, so the RESTful URI should only contain the noun. It should only contain the resource, and the action should be represented by the verb, which is the HTTP. So it means I'm trying to get it. Okay, so this is the biggest problem. So whenever you're designing any URI, there should not be any verb in it. If you're doing it, nobody is stopping you, because as I said, it's like mommy. It's your mom. You can do anything. You can compromise on that, but it's not a good practice. You should always follow the instructions of your mother, right? So it's always a good practice to use nouns. So if you see any of the standard RESTful APIs or the URIs, either Google, Microsoft, LinkedIn, Twitter, you will never see a verb. If someone is teaching you, it's a mistake. Okay, so this is the first thing which is wrong. So how should I have written it correctly? So the same thing would have been written it like this. So what should I would have done? I would written like let's, it's a get API, and the UI should look something like this: HTTP, and then local host 80, right? And then user manage and REST, and then something called user service, and then I just say users, and then one. See this one, users. This should be always a plural noun. The resource should always be a plural noun. Okay, so this is how we do it. This is how we do it. Anybody having any questions? Is it clear? Does it make sense? Everyone is clear on this? We have not in any standard RESTful URI. You should not use verb. It's a crime. Okay, a crime for which nobody will give you a jail, but it's a crime. You should understand that. Make sense? Boliye. Everyone is clear on this? Okay, so now what next I'll do is that suppose my resource is right now user is my resource. Okay, and the user I want to do the CRUD operation. So I want to create, I want to read, I want to update, and I want to delete. So for doing a CRUD operation, how will I define my URI? I'll just give you a sample and you'll understand that how we do it. So if I have to create it, okay, if I have to create it, I'll write a post call, and the URI should look like this: user underscore service, and then users. Okay, like this. And the post call, you also have to provide some kind of JSON body. So for example, if I'm creating a user, maybe I have to provide a name, Vishwa, something like this. So this is how you define. So I'm not talking about the body as of now, so just like try to see only the URI part thing. Okay, so the post call will look something like this. If I'm updating this, so the URI still remains the same only. Same thing happens. The UI doesn't changes. It still remains the same thing, right? Okay. And here it will be user, right? So I'm trying to update the record for a user ID, for a user with a user ID this one. So this is how the put will look. If I'm trying to do a get, so get can be two. If I want to get all, it may look like this: user underscore service, users. Same thing. Just like put, it also remains the same. But because the resource is same, user and user. But what I want to do with the user, I want to create. So I'm indicating it this by the port verb. What I'm trying to do with the user, I'm trying to get it. So I'm using it as a get. If I want to get one record, single record, so in this case, I need to provide user service users, and then user ID. Okay, and now similarly, if I have to do a delete, so it will be user underscore service, users, and user underscore ID. So that for this resource, this user ID, I have to go and delete it. So this is how normally you go and define the URIs whenever you have to build any kind of RESTful APIs. Make sense? Anybody having any doubts? See, Aditya, it's more about, I'll tell you, I will give you a practical example. Your name is Aditya, okay? Instead of Aditya, sometimes somebody starts calling you Golu Molu. What distance? And that person starts arguing with you. What difference does it make? I just wanted to call you. I started calling you Golu Molu. But you'll feel offended, right? That my name is Aditya. You should call me with Aditya, right? Similar logic applies here. When the proponents of the REST, they said that I'm trying to set some standards. Everything is a resource, and resource is always a noun. Okay, and whatever actions that I'm trying to take on that is the HTTP verse. So the resource here is user, and what I'm trying to do on the user will divide it by whether it's a post call, whether it's a get call, whether it's a put call, or whether it's a delete call. So they have done a proper demarcation, right? And at the core of any RESTful services is the resource only, right? And resource is not a verb, it's a noun. Okay, so the URI, what is a URI? URI is a unique resource identifier. Unique resource identifier. The URI definition itself says that URI is unique resource identifier. What it means that if I give you the URI, it will uniquely identify the resource. So when I say this, it means that inside the user service application, there are users and its ID is user ID. So it's identifying that user ID. But instead of this, if I say get users, what is the meaning of this? User services, and get users is a method. And then you say user ID. It's confusing. It's not clear. It's not a standard. Right? So this is the reason. If you do it, nothing will go wrong, but you're not just following the standards. Somebody who is actually following all the rules of the REST, if they try to read your API, they will feel that you are not following the standard. Right? You have not understood the meaning of the REST and you're still trying to implement it. Right? You're one of those developers. I've seen many of them who have been working for years, like 5 or 10 years, and they don't understand what REST is. Right? And I understand 90% of people don't understand. Even the few of the trainers who are teaching you, they don't understand what REST is. They only know, okay, this is how it is done. Okay, so that's the reason. I hope that may make you understand. No, Divyans, whenever it is a RESTful URL, it is just the URI is not complete information. You always have to provide the URI plus the HTTP protocol. That is the complete definition. Just saying a URI doesn't say anything. Okay, so whenever somebody tells you that there is a REST endpoint, they will tell you what is the URI and what is the HTTP verb associated with it. That is the complete information. Just a URI will not tell you what it is, and nobody will tell you that information. So you will need two information: what is the URI and what is the HTTP verb associated with that URI. And then you say that, okay, what kind of operation it is. Does it make sense, Divyans? You can think in that direction also. Yeah. Everyone is clear? Make sense? Are we good? Very nice. Let me see what is there in the slide. So this we have done. Okay. So let's try to see in the slide. So there's nothing much. So let's try to talk about this one here. So whenever you make any request to a service, right? So basically, so there's a client and there's a service. Client is nothing but a service consumer and service is nothing but a service provider, right? Whenever a client makes any REST call to the service, whenever he sends a request, this is known as the request. And whenever I respond, this is known as a response. I think hope you guys are already aware of this, but I'm just repeating it. Any request comprises of following information. First, headers. 2, URI. 3, the request body. Okay. The URI provides the information that where this request is pointed to. The request body contains any information, any data that you want to transfer from the client to the server side. If it is needed, it will be there. If it is not needed, that will be empty. So this is optional thing. Headers provide some additional metadata. For example, what kind of data I'm passing in the body. If it is XML data, if it is a JSON data, if it's a normal text, it's an image, what kind of data it is. It can also contain some additional information, like if suppose it's a login service. So header will say that, okay, this is a kind of authentication service. So all the kind of security kind of things also it can help. Another thing that it can help you with is that, some caching thing if the clients wants to do. So you can provide that additional information around that. So headers contains the information which is the extra metadata. So this is what the request thing. When the response comes, so response also has the headers, which is set by the servers, right? The headers also have the response body. So client asks something to the server, server has processed that and is returning that as a part of the response body. So it has the response body, right? Then it will have something called response code also. So for example, the client requested to create something on the service. So normally the standard response code in that case is 201. 201 means created. If client is looking for some resource on the service and service gets you that, then the response code that is returned is 200, which means that okay. Right, so a different kind of response codes. So this is what there is in this slide. It is talking about HTTP request and the HTTP response. So whenever you make any RESTful call to any of the service, in the request you have a verb to describe whether it's a get call, put call, post call, or delete call. URI, so that you know where you are pointing to. HTTP version, so basically which version of HTTP you are running. Whether you're using HTTP or even HTTP, HTTPS, it also you have to apply there. Then the header, as I already told you, it contains the metadata about the request and the actual body that he wants to transfer. And then when the server gets the data, do some calculation, is ready with the results, it will return with some specific response code, HTTP version, response header. Now, while returning, the server also has to say that, okay, I'm returning data in the JSON format. So that has to be set as a part of headers and the actual body. So this is how the content of both the request and the response looks like. Make sense? Anybody having any doubts here or anything before that? सबको समझ में आ रहा है? Are we guys good? Anybody having any doubts, any concerns, any questions? Everything is crystal clear, guys. So far, so good. Anything that you have to memorize? बताओ. कुछ याद करने की जरूरत है? Perfect. Thanks a lot.
Cool. So Vishwa, just stopping you for a minute, a quick feedback poll that we take during the mid session. So we'll just pause for 1 minute 30 seconds and then we can continue.
Perfectly, no problem.
Thanks so much. Guys, I'm quickly launching a feedback poll. Please share your feedback there and we'll quickly then turn back to the session. Yeah? Thank you so much. You guys quickly take this up so that we can begin with the session. Just 3 more people left. More 30 seconds to go, guys. one person left. Cool. We can continue. Thank you, guys. Over to you, Vishwa.
Perfect. Cool. So Anwar, basically, the version means that any software that you see, will have the different versions. Let me open a new one. Any software, if you see, okay, any software as such, right? It will have the different version. For example, Java ka hi dekh lo. Java has a different version, right? Right now, Java version 14 has even come. Right now, you might be working on the Java version 8, right? So as and when the new advancement comes, the new versions comes up, right? Similarly, HTTP is not an exception, right? So HTTP has seen its own versions, right? So initially, HTTP had the version 0.9, okay? After that, it got updated to the HTTP 1.0. After that, it got updated to the HTTP 1.1, and after that, right now of late, it is HTTP 2.0. So this is the most common version used these days, and also this one is also very much common. So when you're making a RESTful API call, you have to tell that over which HTTP version you're trying to send the request. So this is the meaning of the HTTP version. Does that make sense? Okay, Pratap, now this is I'll tell you, but we are going little away, getting distracted. Let's try to understand how the difference between HTTP and HTTP is. So again, this is initially it was all HTTP, Hypertext Transfer Protocol. Okay, what is the meaning of this? So suppose if I have a server 1, I have a server 2. If I have to communicate between these two, the two application has to talk, okay, over the network, right? The protocol that they follow is known as the HTTP. What is the meaning of the protocol then? The meaning of the protocol is that, for example, if I am, say, I speak, suppose, Mathli. Okay, Mathli is a language in the Bihar. Okay, and suppose you start speaking Tamil. I don't know Tamil and you don't know Mathli. We will not be able to talk. So what happens? We both bring a common, the common area in which we both can communicate to each other, and that we bring it as English. So English is a protocol that I and you are using to communicate over each other, right? So this is what the HTTP is doing. HTTP is a kind of protocol which S1 and S2 can talk to, but it is great, it's fine. So in a normal talking between I and you, we are using English. It's perfectly fine. We don't have any problems, right? But what happens is that this English language, other people also know. So right now, I'm just trying to answer your question, right? I'm just trying to answer your question, Pratap. And you know English, and I also know English, and I'm telling you the answer in the English. But since all the other folks who are here in the class, like Devyans, Avinav, Anwar, they are also all ears. They are hearing our conversation, and they're able to hear our conversation because this English is known to everyone. Similarly, this HTTP was not secure. So whenever one server is talking to another server over the HTTP, chances of others to hear this communication or message were easier. Okay, so what happens? The same thing if so I and you are doing a normal talk, so we can talk in the English. But in the case of the military intelligence system, right? So if there's one military guy M1 and there's another military guy M2, if they have to talk, they normally don't talk in the normal English. They always use some kind of coding, the coding which only M1 and M2 can understand, right? And they also use some kind of secured channels. So same thing is applied to the HTTP. So HTTP add some extra layer of protection cover over the HTTP. Okay, so whenever M1 sends any message to M2, in between all the message gets encrypted and broken down into the different angles, different sizes, different shapes, so that anybody who's heading here will not understand. Suppose and just to give you a comparison, suppose Pratap, you and I know a secret language, and you ask me the same question, something like and I answered you tack walk tack tack talk, right? So you understood and I understood what is the meaning of HTTP and HTTPS, but other couldn't understand. And this is what the HTTPS brings to the table, right? It brings a layer of security on the top of it, so that whatever messages that one server is sending to the other, only these two servers will understand. All for the other people, it's just a noise. They cannot understand anything. So HTTPS brings an extra layer of security over the HTTP. And of late, since we know that there are so many security threats, it's always advisable to, if you have any public facing website, it should be always on the HTTPS other than HTTP. Does that make sense, Pratap? Is it clear? Anwar, does that answer your question on the HTTP version? Everybody is clear on this question. HTTP, HTTPS is very important, right? Was the example convincing? Do you guys agree with me? Perfect. Cool. So let's try to take our wheel further. Let's see what is next. That I've already explained you how to make. Okay. One very common thing which again people miss, I just want to cover it here, is that when you're building your RESTful APIs, have you guys, how many of you build RESTful APIs in Java? Just say yes. Quickly tell me yes. We are running out of time. How many of you build RESTful APIs in Java? Okay. No, yes, no, yes, no. Okay. Is it something like that? All the, okay. Okay, most of you have not done it, not a problem. But for those guys who have done it, can you guys, anybody tell me what is the library that you have used in Java to build a RESTful APIs? Anybody who knows aware of? The library that we have used in Java, Jex. Jex is a library, no? Pratap. And that is why I tell you, half knowledge is very damaging, Pratap, right? Either you should have full knowledge, or you should not take any little knowledge. Little knowledge is always dangerous. Because you have told Jex, like, anybody else? Okay. So what happens is, Java, what happens is that in Java, since you guys have to work on Java, so I'm just, predominantly mentioning it. Java, whenever Java makers realize that there's certain thing that is always happening, they try to set some standards there. They try to set some interfaces for that. So for example, if Java has to connect to a database, so for the initial release of Java, they made it something known as JDBC. So JDBC is a library written in the Java which helps you to connect to the database. But then they later realized that using JDBC is a complex thing. People are not using it, right? So what they did is that they created some APIs known as JPA, which is known as Java created something known as JPA, Java Persistent APIs. And these are nothing but the contracts or interfaces. And then Java enforces that anybody who wants to connect to the database, any library providers, who wants your application to be connected to the database, they should follow the JPA. And then in the market, the different players comes, the players like, Hibernate, the players like Spring Data, who comes in the market, and they provide the implementation of the JPA, and then you are able to connect your Java application to the database. So you must have heard Hibernate and the Spring, right? They helps you to write ORM layer to connect your Java to the database. Similarly, when the REST came into the picture, right? Java makers in their release, they realized that now REST people will start making RESTful APIs in the Java. Now to keep it a standard, so that whether I work, whether you work, or some third person sitting in the US is working on the RESTful APIs on the Java, everything should be a standard so that every code should be matching, right? to do that, they exposed they exposed a kind of the regulations or the contract or the APIs which has to be followed, and they called it JAX RS. So JAX RS is the standard, the contract or the interface which Java makers has defined that any library or any third party who is implementing the RESTful APIs, they have to abide by the standards of JAX RS. And then when this JAX RS was defined, the different market vendors, for example, REST Easy, Jersey, right? Something like Spring. These all are the market vendors who are implementers of JAX RS. They're implementers of JAX RS, right? So whenever you have to create any RESTful APIs in Java, you have to either use a library called REST Easy, or you use something called Jersey, or you use something called Spring to create your RESTful APIs. Does that make sense? And this is what, so JAX RS is just a contract which the Java makers have provided. And there are the different market players, the vendors who has implemented this JAX RS, and they're saying that, okay, we have the most efficient implementation of JAX RS. It's now you, the application developer, who have to decide that you have to go with the REST Easy, or you have to go with the Jersey, or you have to go with the Spring. And then you pick that framework and then use that to create your RESTful APIs in the Java framework. Does that make sense? Is it clear? Bolo, are you guys good? Anybody having any doubts? Cool. Let's try to move on to the next thing, which is that. Guys, just give me a second. Just give me a second. I'll be right back in a minute. There's someone at the door. Just sorry, guys. Sorry for that. There's someone at the door, and he was getting crazy. Perfect. So let's get back and let's try to see what we have left now. So this is done. Okay. Authentication and authorization. Very nice question. One of my favorite topics. So can you guys tell me what is the difference between authentication? What is the meaning of authentication versus authorization? This is a very common term, right? Can anybody help me understand what is authentication and what is authorization? What is the difference between these two? Simple words, quickly. Authentication and authorization, what is the difference? Authentication means verify. What is authorization, Pratap? Authentication, validating credential. Authorization, validating level of access. Very nice. Perfect, Divakar. Very good. Very good. Very good. So I think no point discussing on that because he's already answered it well. So authentication is about, checking. So suppose this person came and he's saying that he is Vishwa. Okay. And this is the system. Now the purpose of this authentication in the system is that to check that he's saying Vishwa, but he's Vishwa or not. This is the purpose of authentication is. So if the system is doing the authentication, he'll make sure that he's saying Vishwa, but he's Vishwa or not. This is what it tries to check. So the purpose of authentication is to check whether the person who is saying is he himself or not. This is what authentication is. Okay. And then what is authorization? Vishwa is saying that I'm the admin. I'm the admin of the Facebook. Help me know the password of everyone on the Facebook. So this authorization system will try to check whether Vishwa has the access to become the admin or not. And only if he's an admin, he will be allowed to change the passwords of all the other users. Otherwise, he will not be allowed. So this is the basic meaning of the authentication and authorizations. Cool. Everyone is clear on this? Everybody agrees? Do you guys agree with me? All good? Shall we move on? ठीक है. उसके बाद क्या हुआ? ठीक है. So I'll try to give you a little history. So when we started building the APIs, right? So we have a client, we have a server. In the very initial days, ideal days, right? For example, in the humanity, it was said that during the Ramayana period, there was no people don't used to there were no used to be no thieves. No things were getting stolen. Similarly, when the IT industry just started, right? People were more involved in doing the real life robberies and real life thefts. They used to go to the bank and rob it. So initially, when the the applications were created and the client was talking to the server, at that time the robbery don't used to happen, because that time very few things were on the internet, right? So that time we only created the RESTful APIs and we're happy. But soon and soon, more and more people started putting their data on the internet, and people started realizing that data is the new cool thing. And so we should start not only robbing the banks and the money, but we should also start robbing the passwords of the other people, because it's very important, right? So that is when people started, the few miscreants, the people like them, they used to rob the data in between the client and the server. Okay, so a client is sending something to the server. So sometimes they used to morph the client and get the data from the server, and they started robbing it. And then when the people started realizing that there has to be some kind of protection, there has to some kind of security here. There has to be some kind of security here. And that is how the whole principle of authentication started. Authentication started. Right. So now what authentication means, that only if the client authenticates, the server will send the response. Otherwise, if the client is not authentic, the server will not send the response. This was the first basic way of securing the APIs. No, the first step towards securing the APIs happened. So what was first one? The first was the basic authentication, basic auth. A typical basic auth in which what happens, I have a client and I have a server. I have a client, I have a server, and client will send the username and password, and obviously the username and the password will be the encrypted format. It will go to the server. Server will check, okay, see, it is the same username and it is the same password. If it matches, then it will return the response. If it doesn't match, it will return invalid user. Okay, and this is the meaning of the basic authentication. Anybody having any doubts, any questions, any concerns? Basic auth clear hai? Why it is needed? What we do in the basic auth, normally a client sends username and a password as a part of the request in the header to the server, and the server checks if that username and password is matching, and then only return the response. And this is how it is secured. Okay. Do you guys see any challenge in this method? Or it is good enough? Initially, when it was started, people were so happy. They felt that, okay, again, we have got a great solution. It has solved all the problems of the security, right? It's just like putting the lock on the main door. But can we stop the robbery or the theft by just putting a lock on the main door? No. Still, thieves are smart enough to come inside your house and loot many things, right? So similarly, do you think there is any challenge with this approach of, in this first way of authentication? Guys, are you aware? Are you awake? Only 10 minutes left. Please show your energy. After that, you are all free to enjoy your Sunday night. Any problem with this approach? Any issues in this? If I try to, secure it with the user and a password, do you see any challenge in this? Or you feel that, okay, it is very much secure, there's no challenge? You can say this also, it's fair enough. Because many of the people felt so when it was started at that time. Credentials can be sniffed over the network. Okay, so again this was right. So that is why initially whenever you have to do the authentication, initially you used to do the HTTP, but later on it was moved to the HTTPS. So that problem almost got solved if you started using HTTPS, because now your credentials are no more in a normal form. So you do it over the HTTPS. Any other challenge? So this authorization will take care of later, Aditya. So I'm not worrying about the authorization as of now. I'm just talking about, say, I'm only trying to do authentication, but just providing username and password, is it sufficient? Yes, that is a problem. See, this username and the password, since I'm only dependent on the two things, which is a username and the password, right? Since I'm only dependent on the username and the password, if anybody who knows the username and the password, they can start using it, right? They can start using it and they can misuse this username and the password, right? Because only first time the client is sending their username and password, and suppose some wrong person, someone in friend, some your dear friend who faked to be your friend, and they asked you your username and password, and you out of the courtesy you have told that this is my username and password, they will start misusing it, right? So there is no second check here. So this was good, provided everything stays in the ideal condition, but this again had the challenges. And this challenge was fixed by something known as the bearer auth. So this bearer auth, and there is OAuth was also there. I just don't want to rush on this because this needs some time. So I'll just stop now because I think it's already time. I don't want you to stretch on this because this is already second session. So if you have to stretch, we'll stretch on the last day. So I'll just stop here. But any questions or any doubt that you guys have for the today's session or of the previous session or anything related or the relevant, I'll try to invest next 5 minutes on that, because asking and clarifying your doubts is more important than anything else. So guys, please feel free to ask any question, relevant or irrelevant. I'm totally fine with that. Please feel free to ask in the next 4 minutes. Clock is ticking and you have limited time. Please do ask. You're right, Mamta. Any questions, doubt, anything? How's the speed going in the class? It is fine. It's going slow. It is going fast. Are you guys getting it? मजा आ रहा है? समझ में आ रहा है? Meanwhile, Sankalp, you can also raise that the session and poll if you're planning to do that.
Sorry, I didn't hear you. If you could just repeat back.
I'm saying that there will be a session and poll also for the student, feedback poll. You can do that now. I'm saying that.
Acha, okay. Cool. So, I mean, with that, I mean, I guess the learners will not be able to put up the question in the doubt section.
Achha, okay.
Yeah. So let's wait for once all the questions have been taken, then we can put it up. Yeah.
Cool. Any doubts, guys? So the last few minutes I normally keep for the doubts. So you still have 3 minutes. Please feel free to ask anything that you have in the today's session or the previous session. सब कुछ clear हो गया? Everything is clear? No doubts? Great, guys. You guys are really great. Cool. That in that case, I think you guys don't have any doubts. So maybe Sankal, you can go ahead with the feedback poll because these guys are very clear. They don't have any questions. So all to you then.
Cool. I believe as of now you guys won't be having any questions, but if you do have, guys, please post it in the discussion forum of the program. And with that, I'm also launching a feedback poll. Please share your valuable feedback here. With that, thank you so much, Vishwa. I mean, certainly a very interesting and very insightful session here for the learners. I hope both the sessions have helped them, and it will certainly help them in their professional journeys. With that, happy to host another session with you soon. Thank you so much for your time. Yeah.
It was same here. Thank you. Thanks a lot, guys. Good night. Take care, and we'll see you next week. Thank you.
Thank you. Hey guys, please rate the session before you leave, and thank you so much for attending the session. Take care and stay safe, guys. Thank you. Guys, thank you so much. Have a good evening and stay safe. Thank you.